I'm Shannon Seaver, and today we're looking at linear equalities in two variables. Actually, this says A, it really should say B. It's part 2. And on the agenda for today, we are looking to graph a system of linear inequalities. So remember, a system of equations are two or more equations, and so therefore a system of linear inequalities is two or more inequalities. And here we are looking at a set of lines that we need to draw, and let's look at the first one. And these happen to be in mx plus b form. So the slope on this one is 1, and the y-intercept is 5. So I can go up to 5, and it's a rise of 1 and a run of 1. So I can go ahead and make this line connecting my dots all the way down here. And by the way, I just noticed something I did wrong. One of the things you need to remember when doing this is to look at what kind of inequality it is. Here, it's just a less than. So because of the fact that it's just a less than, we are going to make dotted lines here instead of solid lines, because it does not include this line. Okay? Now, one of the things we need to do is shade whether it's above or below. Anytime you have y less than mx plus b, you're going to shade below. Okay? If it's y is greater than mx plus b, you're going to shade above. So in this case, we have a less than, so I'm going to shade down below it here. Okay? So now, let's do the other one, and I'm going to change my pen color. Let's go with blue. Okay, so now we have m as -1 from this right here, and we have b as 3. So let's go up to 3 and put a point here. And since my slope is -1, I'm going to fall 1, run 1. Fall 1, run 1, and so on. So now let's connect those dots. And by the way, notice that it has an equal sign here, so it will be a solid line. Oops, sorry about the not straight line there. But you get the picture. It should be straight. Still can't draw it straight. Okay, so it's a solid line going this way. And now it says less than, so again, we're going to shade below. So now what we need to take notice here is where both shades are. So I'm going to highlight that, because that is the area in which our solution set is right in here. Anything in this area. So any point that is found in the shaded region here, the yellow shaded region, can be a solution of both system, of the whole system. Now, I want you to take a moment to try this one, and notice that this one is in standard form. Because it's in standard form, sometimes it's easier to find the intercepts and then solve, or you can solve for y and do it the same way we did on the last example. So pause the video and try it on your own, and come back and check your work. Okay. So hopefully you've tried this on your own, but I'm going to walk through this anyway, and you can check your work as we go. So if we're going to graph this by intercept, that means I could put a 0 in for x and solve for y. Let's do that. I'm going to put it down here. So -3y, and I'm just going to think of it as it equals for now. Y would be a -2. So my first point on here is going to be at -2, right here. Okay, so let's do this for x. Putting a 0 in for y, we have 2x equals 6, so x is equal to 3. Here's my other point. Okay, so we have our two intercept points here. Now we need to look at this sign right here. It's a greater than or equal, so it's going to be a solid line. So let's see if I can draw this as straight as possible. There we go. Okay, so there's our line. Now we need to figure out what side of this line should be shaded. So I'm going to pick the point 0, 0, just because that's so easy to use. So we'll have 2 times 0 minus 3 times 0 is greater than or equal to 6. Well, 0 is greater than or equal to 6. That's a false statement. So we're going to want to shade the other side of this line. Not the side of 0, 0, but the other side. So here we are. Now let's look at the other equation. I'm going to change my pen color. Oops. We're going to go back to red. Okay. So now we're going to graph by intercept again. So let's look at when x is 0 again. So we have 3y equal to 12. So y is going to be at 4. Let's go ahead and graph that at 4. Now we'll graph the x-intercept, 4x equal to 12. So x is going to be 3. Here's our graph right here, our point. So now what we're going to do is notice that this is a less than, but it doesn't have an equal sign, so it will be dotted lines all the way down. Okay, now we need to test a point. Let's pick 0, 0 again. So 0 less than 12. Well, that is a true statement. And being that 0, 0 is on this side of the line, I am going to shade on this side. Now, let's highlight the region of feasibility. We're going to do that by looking on the inside of where they both are shaded. And right there is our region in which we could have a solution for both lines. So the yellow area is the solution set of our system of inequalities. Okay, so let's look at an application problem. Here we have a graph of temperature and precipitation effect, whether or not trees in a forest can grow, and at certain levels of precipitation and temperature, only grasslands and deserts where it exists. So if you look at here, we have the forests on the top part, we have the grasslands in the middle, and we have deserts in the bottom. We have temperature along the bottom and precipitation along the side. So it said that forests can occur when the temperature is greater than 35, and when this equation, when this line, it can occur above this line right here. Grasslands can occur if the temperature is above 35, and both of these, it's below this line but above this line right here, and that's what these two lines are. And then deserts occur if the temperature is above 35 and the precipitation line is below this line right here. So we want to look at point A, and that's given to us right here, and it looks like point A is at, let's see here, 50, 30. And we want to prove that point A does indeed work for forests. So what we're going to do is we're going to look at the two constraints for forests here and prove that both constraints work. So look at temperature. This was our temperature is 50. Our rainfall was 30. So T is greater than 35. Well, 50 is indeed greater than 35, so this one works for sure. Now let's check the other one. 5 times 50 minus 7 times 30, is this less than 70? Well, we have 250 minus 210. 250 minus 210 is 40. So 40 is indeed less than 70, so this one works too. So yes, point A is a solution where the forests occur. So this is one of the examples that you might be working with at the end of the chapter here. If you have any questions on today's lesson, please bring them to class tomorrow.